All right, so let's start this number 6 here, which is about within the type 1 and type 2 errors. First of all, I like to always write down my HO and HA, and so whenever you walk into a building, you assume that the building is safe, and then HA would be that the building is not safe, all right? So do you see here I write down what I wanted you to find? So let's do a type 2 error. So let's look over here to the right. A type 2 error is that HA is true, building is not safe, but we say it is safe. So the deal is here, stating that the building is safe when it's not safe, the answer is D. Okay, let's go look at number 7 in the talking about lead levels. So this is again, the lead levels are within limits, and AJ is that the lead levels are not within limits. So they want to know about a type 1 error, so let's look at this chart. And so that is the null hypothesis is true. So that means that it is safe, but we're going to say it's not safe. Now, if we're going to say that's not safe, we're going to close it. And so we are going to close the park when the levels are an allowable distance. So the answer is D. Okay, let's do 8. Okay, so whenever you look at a female, you assume that she is not pregnant. And HA would be is that she is pregnant. Okay, now they want to know, so a doctor informs a patient that she is not pregnant when in fact she is. So what do we know here? That HO is true, but we go with HA. HO is true. HO is true. Okay, silly Schwartz, HA is true. In fact, she is pregnant, so HA is true. But we go with HO. I'm sorry, I have to think about this. So this is a type 2 error. And a type 2 error is a false negative. Okay? Okay, let's do number 9. This is just a basic question. In formulating a testing significance, the null hypothesis is usually the one that has no effect. And 10, a researcher developed scanners for hidden weapons at airports that has concluded that a new device is slightly better. So if they went with a new device, that means they rejected HO, right? And so that means here, if 0.05 is my alpha, that means my p-value is between 0 and alpha, so my p-value is right here. Now, let's let my new alpha be 0.1. Would I make the same decision? And the answer is yes, because it's still less than.